Hi, in this session we will discuss about contextual retrieval. So this is one of an enhancement in order to get more accurate answers in retrieval-augmented generation. So we already discussed about what is RAG and what are the common issues in RAG and how we can improve in each and every processes. This is one of the technique where we can improve the overall accuracy of the uh, output of the system in retrieval augmented generation. So here, actually this method was proposed by Anthropic. So here, this particular method is called contextual retrieval. It addresses a common issue in traditional RAG systems. So here we know like we do chunk or split the bigger document into smaller chunks in order to easily handle the processing of embedding. So while doing the chunks, like we already discussed how we can do, there are different methods of chunking. On that we discussed about semantic chunking, such that we can group all the semantic similar content in one particular chunk and pass it to and give it to an embedding model to embed it. So we are going one step further here. So what's the main problem here? Like individual text chunks often lack enough enough context for accurate retrieval and understanding. So here what this actually means is that we have a chunk, okay? Even though we have a chunk, we formulated the chunk in such a way that the semantic meaning stays within these chunks. It will not overflow. We try to minimize that overflow. So now we need to make sure like where exactly this chunk fits in the entire document. So if we can able to pass that information as well along with the chunk, then it is very easy or it is less complex to a final LLM to generate a more accurate answer. So that is the main concept here. So here that's what a contextual retrieval says. So contextual retrieval enhances each chunk by adding specific explanatory context before embedding or indexing it. Okay, so we know why we do embedding. So we do embedding, and then based on the semantic search, we pull the embedding acts as an index. Okay, then we have an actual document. So we do a semantic search in the index like the embeddings, and then from that we where the documents is pointed, that documents we pull it out and then pass it to the LLM for augmentation. So that's the main technique behind RAG. But how we can improve? So we are going to improve by using contextual retrieval. So we are going to add a simple explanatory context to that particular chunk before embedding it. So we are going to we are having a chunk, and then we add a small context like what about this chunk and where it fits in the document, and then both together we embed it into the embed and then store it in the vector database. So that's the main technique we are going to use here, that was proposed by Anthropic. So this preserves the relationship between chunk and its border documents like the actual bigger document, and significantly improves the system's ability to retrieve and use most relevant information. Definitely, because if you give a small context like what about this chunk and then where it fits in the document, and then if that information was there, it is very easy for retrieving a specific or most accurate chunk related to the answer, and then we can pass it to the LLM to give the final answer. Okay, so these are some experiments created tested by Anthropic. So contextual embeddings reduce top 20 chunk retrieval failure by 35%. Combining contextual embeddings with contextual BM25 further reduce the failure rate by 49%. So these improvements highlighted the potential of contextual retrieval to boost the performance of AI-powered question answering systems or a chatbot, especially RAG system, making more accurate and contextually aware. So we know like context is the king. Like if you provide a correct context to the LLM or a answer generating LLM, then definitely it will give you most accurate answer. So we are thriving to get most accurate answer for the given question. So this is one of the way like where we can tune to have the context within the embedding such that it can able to retrieve correct documents and then provide those documents to the LLM and we get the correct answer. So how we are going to do, so we know like we are going to break the documents into smaller chunks and add contextual information to each chunk, embed them and store it into the database, perform similarity search to find the most relevant context, and then along with the context we have that chunk. So use LLM to generate the answers using questions based on the retrieved context. Okay, so this is how we are going to perform, and I will show it in the demo. So before that, this is a actual paper, the actual technique proposed by Anthropic. So here you can see, I will share the link as well. This is very good blog post on Anthropic, on contextual retrieval by Anthropic. Please go through this. This will give a detailed overview like how we can implement. So this is the basic technique how they are proposing. Like we have a corpus of documents and then we chunk it, and then we run a prompt on every chunk to situate within the document and then get the context of that particular document within a very brief context, and add the context with the chunk and then embed it and then store it in a vector database, and then finally we are retrieving based upon the context. So it will drastically improve the performance of RAG system. So I'm going to use more or less the same technique in the demo. So here is the prompt. So how they propose to create a contextual chunk. This is the original chunk. The company's revenue grew by 3% over the previous quarter, and the context for the chunk is from SEC filing and ACME Corporation performance Q2. So this give like we are going to pass each chunk to the model and then get the context. So we are going to pass not only the chunk, we are going to pass the document, the entire document plus chunk, and find out the context related to the chunk and the document. Give a brief description of the context, and then we are going to embed the context along with the chunk in the vector database. So this is actual prompt proposed by Anthropic, and we are going to use the Anthropic model itself for getting the context. So we have the document, whole document we are passing, and then the chunk we want to situate within the whole document, chunk content and chunk, and then we are giving the prompt. Please give a short succinct context to situate this chunk within the overall document for the purpose of improving search retrieval of the chunk. Answer only with succinct context and nothing else. So give only that particular context and don't go beyond that one. So this will give a very precise contextual text for each and every chunk and where it situates in the document. So that will improve the RAG. So let us see how we can actually implement in the following demo. Hi, this is a demo part for contextual retrieval. I'm using a Collab notebook. So these are preliminary steps just to enhance visualization of the output. Here I'm going to load the same document what I used previously. So this is the document the data set we are going to use from the Hugging phase. So where it has a system prompt, like usually we don't have this one in this data set, and then we have the user question and then corresponding answer for that one. So the same data set I'm going to use here. I'm taking only 10 records of the one. So obviously you need the token, Hugging Face token, store it in secrets. Then so this is the document content. So what are the records, like what are the columns it has, like system, user and assistant. The assistant is the actual document we are going to embed. Okay, so this because why I have taken this particular data set is that it is more related to finance, plus if you in real time what we do is that in production systems we take the PDF documents. Mostly lot of the information was stored in PDF documents, like those are unstructured documents in any business or enterprise. So that one we will parse it and extract the text and then do the chunks and then finally do the embedding, all the stuff. So that is a end-to-end pipeline. So that I will discuss in a detailed video how we can do taking the PDF document and do the process end to end, and then finally have a question answering system or a RAG system based upon your own document. So here this one this is a simpler demo for that particular how we can implement a contextual retrieval. So here if you see the content is actual the assistant record, like the column the assistant which for the particular record. So that is the actual content. We are going to do embeddings to show like I just first taken a record and then showing what it is actually. The physical and monetary pulse are two main tools. So this is the first record. So now we are going to use a specialized chunking mechanism in order to have or in order to group all the semantically similar sentences or paragraphs in one particular chunk and then do the chunking. So this I already explained in a previous video about semantic chunking. I'm going to use the same semantic chunking here because so there are so these are the processes where we will use in RAG systems, like semantically chunk everything and then do the embedding and all. So in each and every process we are trying to improve the performance such that the final outcome will be more accurate. So that's why instead of going for a normal chunking mechanism, I'm using a statistical chunker. If you want to know more about this one, I clearly explained in the previous video. Please check that one. So I'm using the same semantical chunker. So I'm using OpenAI's encoder here, and then I'm doing the encoding. So after doing the encoding, just I'm running the statistical chunker on that particular document and then getting the outputs here. So this I clearly described like what this means and what are the benefits we get using this chunking mechanism in the previous video. So I'm displaying the chunk here. Okay, so here there are three chunks for one particular record here, record in one particular row. So this particular first record has been split into three chunks. So we are interested only in this assistant column where this gives a brief answer, like this is the actual content we need to embed. So that content has been split into three chunks that has been displayed here. Now is the actual work we are doing to generate the context here. Okay, so we are going to use the Anthropic. So and then we need Anthropic API key to generate the context. So we already discussed how we are going to do. So we are going to pause each chunk and then along with the document, the entire document, and then chunk we pause, and then we ask Anthropic model, especially we are using Claude 3 IQ. This is enough for our purpose because this is one of the model which is most economical, and then it serves our purpose. If you want to see like what are those models, I will share the link as well. This is about Anthropic Claude. We are going to use Anthropic Claude 3 IQ. This is the model. So you can see that input tokens is 20% per million token, and it has cache as well. And then we are going to take into consideration of the caching the document and the prompt as well in Anthropic. So we will leverage that one. I will show how we can do that one. So here, yeah, I will explain that thing. So we are going to use that Claude 3 IQ model, and then this is the actual document context prompt. So I already explained this one. We are going to use the same proposed prompt and how we are going to define as proposed by Anthropic. So the blog post they given like how we can provide the context and the document. So I just little bit enhance the prompt So this prompt, please provide concise context 2-3 sentences that situates the chunk within the overall document. Focus on what section topic this chunk belongs to, how it relates to broader document theme. Add any key context needed for search retrieval. So this one you can modify. You can modify based upon your own requirement, because that can further improve based upon a business use case. So I just given a little explained version of the Anthropic prompt here, and then this is a simple function. So what I'm doing here is that, so you can see the maximum tokens and temperature. So temperature is one of the main consideration, like whenever you are working with large language model, keep in mind based upon your use case you should set the temperature. So temperature is actually means that we are how far it can go beyond the given context, like how far it can able to generate its own content. So that's the main lever we are we can assume that it is a knob where we can tune. So if the temperature is 0, it won't deviate, like it should give only whatever we provide, like the context or prompt. And if you want to give some liberty to the model to generate content based upon its own knowledge, then we can increase the temperature. So if we increase the temperature towards 1, then it has more freedom to generate the content based upon its own trained knowledge. So this is the bandwidth here. Like if it is 0, it should not deviate from your own content or prompt, and it goes on increasing like that. And if it is 1, then it has a full freedom to generate whatever it wants. So it depends upon a use case. For some reason you should need more creative output from the large language model, then you can go to 1, temperature as 1, so that it will be more creative. But for some situations where you don't want most creative, you want to answer only to the given context and the prompt, then it should be 0 or 0.3, something like that. So that depends upon a use case. So I make it as 0 because we want to give the answer based upon the given context and prompt, nothing else. That's it. Okay. So here the message, this is the message template here. This of course I am following the Anthropic specified template. So here text, and then text. What is the text actually? So we are giving the document, okay, the entire document here, and cache. So this is one thing I want to specify here. So we are caching that. I think I had a link somewhere here so that I can show you. Okay. So this is a cache control, like a cache control in the sense like there is a like what we can say, there is a possibility that we can able to cache the document and the prompt in the Anthropic. So what we are doing, we are going to send the document and then chunk by chunk to get the context for each chunk. So if you do each and every time, let us assume for in our use case we are using very small document, that's fine. But in a production systems, definitely you have a very big document ranging to 500 to 600 pages, where it can easily fit in the context length of the given model. But every time you can't able to send it, right? So once every time if you send it, you will consume more tokens every time, and then you are going to use more resources, so that obviously you have to pay more. In order to cut short the one, we can cache that one. So what is caching? So first time you are sending, we are instructing that large language model, in this case Anthropic Claude 3 IQ model, such that I am giving you the big document, please cache it, and then successfully I am going to give chunks such that you will use the main document for using for answering these chunks, context, or whatever it is. So this is one way where we can drastically reduce the token size by first pausing the bigger document and caching it in the ephemeral, and then we can use the chunks to respond to the main document and get the context. So only one time we are going to pass the main document, the bigger chunk, bigger document, and the successive turns we are going to send only the chunks. So we are caching the main document here. So that is the main technique we are using here. So this caching technique is available in all other providers as well, in OpenAI, we are doing in Anthropic, in Google as well. So apart from that, then we are passing a chunk context prompt. So this is the chunk context prompt and the chunk content. So this is actually the chunk. Okay, the chunk is a smaller chunk. We already chunked from the bigger document. So we are pausing it, and we are asking to get the what is that context for the particular chunk, so that we can embed it. Okay. So this is a simple function here, and I'm created, and then now I'm actually activating it like chunk context list, and then for chunk list in chunks underscore 0. So chunks underscore 0 is the actual chunk here. If you see, where is the chunk? Yeah, chunk underscore, yeah. So this is the chunk. Okay, so this holds all our chunks. So in our case we have only 3 chunks for that particular first document. So it has all those chunks there, and then we are running the situate context function such that it will do the work what we require, like it will pause the main document and then 3 chunks one by one, and then get the context. Now I'm printing the actual context, like the generated context from the Anthropic. So we already sent the entire document and then the chunk. So this is the context generated. So you can see this, we have 3 chunks. So for the 3 chunks we have 3 contexts generated here. So you can see the chunks, context here. So this chunk belongs to a section of physical policy, which is one of the 2 main goals. So now if you can see the chunk here, this is the chunk which discuss about fiscal policy and how it has been used as a tool in the government. So now for that one we got the context. So what we did, we paused the entire document and that specific chunk. So the API returned, like the Anthropic do the processes like we use Claude IQ here, and it does the processing and then give the context. So now we have so it gives a detail like what model has been used and all the stuff. Yeah, so input tokens and output tokens. Okay, so we got the chunk context here. Okay, so now once we got the chunk context, then we need to embed this chunk context along with the chunk in the vector database, such that when a user asks the query, it will semantically search, because we already have the context plus the chunk. It will give you the most accurate document, and then that one we can use it for answering. Okay, so this is the process, like I'm generating some metadata plus adding chunk text and chunk context. First we are having chunk text and chunk context. This you can switch, like either you can have chunk context first and then chunk text, so that you can play around depending upon a use case. Actually the proposed method was you can use the first chunk context and then chunk text, but now I purposefully switched it, first having chunk text and chunk context to check the retrieval ability. It works fine for our use case because ours is not a very complex use case here. So now I'm printing over the first 2 entries and then see how it looks like. I'm saving it as a just because we already have the one. I'm saving it as a JSON NL file, and it will be very easy for us to embed that one in the final database. So this is what we get. So you can see here. So we have unique ID generated. This is generated in the system. Like I am generating that one, and then system prompt we don't have as in the record itself. If it is there, then we can have it. So this I'm showing like why means like you can generate like whatever metadata you want, such that if you give enough information in the metadata, then it will be easy for retrieval along with this context. So there are different points like a situation where we can enhance. So having a good metadata, having a good context within the chunk, and then these are the methods like how you can improve the retrieval capacity. Like that is the main base of the system. If we can able to retrieve most accurate documents, obviously we'll get most accurate answer. And then text. So here text you can see here. Since I have the chunk text first, and then I do have the context at the end. So I added the context at the end here. So you can see this context. Okay. Okay. Where is the context? Okay. So here you can see I escaped with the new lines, so that we can have separated chunk and then context here. So now you can see this chunk belongs to a section of physical property. So what I did, I'm just stitching together the actual chunk and then the chunk context, such that we can pass together these things to embedding model and then embed and then store it in a vector database. That's it. Very simple. So this is how I generated. I already explained, either you can have first chunk context and then chunk text. I purposefully switched so that just I want to test like how it comes out when we try to query. So that's about that one. And then I'm using a quadrant. We can use a quadrant in memory DB. I have already shown this how we can use in-memory DB in previous videos, but in this video particularly I want to show you like how you can use actual quadrant cluster running on a different cloud system. So that is how we usually the productionized system will be using. We don't go for in-memory databases there, so we will use or we will leverage any third party or a cloud service provider which runs this database for us. So in order to explain that, I spin up a quadrant DB in quadrant, and then I'll show you how we can connect it. So obviously we need to have a API key for that one. So this is a quadrant cloud. You can go with free tier is enough for us, no need to pay anything. So here you can sign in and then get the API credentials. Once you get that one, same as before, if you're using Google Colab, you can use it, you can save it in the secrets and then get the key. Or if you're running as a Python script or creating any app, use a .env and then get the credentials here. So now I am running the initiating the client here. So make sure you should get this URL from the dashboard of Quadrant, and then you need to give the collection name, and then vector size and distance cosine. Like I'm using this particular transformer to create the embeddings. So based upon that, this is a vector size. So it depends upon your use case. Either you can go with OpenAI or any other provider, but make sure the compatible LLMs like the final generation LLM and these things to be compatible. Okay, we already discussed like how it has to be in the previous videos. Okay, so now I am pushing I created the embeddings there, and now I am pushing the embeddings into the quadrant DB. So this is a simple script to push the embeddings into quadrant DB. So we have the structure like how it is, right? We have a row ID, vector, and the payload. Okay, so this is how I giving the structure for that particular database, code and database. Of course, you can give depends upon your use case, whatever you want, and then have the vectors and then payload. So now for the particular collection, I'm storing it there, and then I'm asking a question directly to the database now. Explain trade-offs. This is the query, and then we need to embed the query and then get the semantically similar meaning documents. So I'm getting that like I'm passing the query and then searching the quadrant database here. So obviously we have only 3 chunks. So now if you see, this is the output we got. Okay, I'm just printing a system prompt as well. We don't have actually. So this is the text. The key trade-offs. So I asked what is explain trade-off. That's it. So the document contains only 3 chunks, and then there are 3 different chunks. So now if you see, the first one is the key trade-offs are. So if you see the chunk here, this is the chunk. Okay, so the first chunk will discuss about physical monetary policy, but in the second chunk second chunk defines about monetary policy reference, and then third chunk clearly starts with key trade-offs are. Okay, so it got the correct document based upon the user query. Okay, the key trade-offs are its physical policy have more trigger impact. Okay, so I asked only explain trade-offs, so it gave the correct chunk here, and this chunk summarizes. So we got the context also. If you remember, like we have separated by 2 new lines. So we have a text and then 2 new lines, and then we have the context here. So here if you can see, we have this one. Okay, so this is the way like how we can implement contextual retrieval, and also there are only 3 records here. I just want to print all the records. Okay, so this is how we can improve the accuracy of Retrieval-Augmented Generation by implementing contextual retrieval. So in the previous video, we implemented semantic chunking. That's instead of going for a simple chunk method, we use a semantic chunking. So that is one way how we can improve, because all the similar paragraphs or sentences having the similar, most similar semantically meaning items are grouped together and then do the chunking. So on top of that, we go one step further. So before embedding, we pass those chunks to a large language model and get the context. So we pass the entire document, and also we pass the chunk and ask the large language model to give me the context and a small brief note, like what it actually what the chunk has, like what is the brief description of the chunk and how it situates in the main document, all those stuff. So we got that one, and then we do the embedding chunk plus the context, and then we try to query the vector database here. So it gave the correct answer. Like obviously this in this demo we did have only 3 chunks, and then but still on that one it worked well. Like if you want to have more complex thing, and then like with a many big document and lot of chunks, so there definitely it will be very helpful. Like you can clearly see the difference, because I already tested in a bigger document as well as a complex document, especially while using a complex document with different data points like graph, charts, all those stuff. I tried that one, it worked well. If you want, I can give you a full-length video how to parse the document and then get the information and then store it in a vector database and do the semantic chunking and all the stuff. I will explain in detail. So this is a demo like how we can leverage contextual retrieval proposed by Anthropic for our RAG system. Thank you.